Hello, my name is Muhammad Reza from University of Indonesia, Technical Electro and Engineering International Program. Today I will be presenting my purchase counter for my embedded system project. My Mahasiswa number, my university number is 2306254874. And over here we have a purchase counter which utilizes both software and hardware. We're using a microcontroller, which is the Atmega 328P on the Arduino Uno microcontroller board. The origin of this idea was that my parents are opening a cafe, which is gonna have some customers. So in order to count the customer transaction correctly, I decided to create a customer transaction tracker using a PIR sensor, a HC-SR501 to be exact. And over here we can see how it works. I also made it into a tip box, and if we were to hold it out over here, the green LED is gonna turn green, and then it's gonna revert back to the red LED since it is in the repeated trigger mode for the HCSR501. And over here, I have created a flow chart which visualizes how the whole circuitry will work. And over here on the right is going to be the real life circuitry. Over here we have the PIR sensor, which is a signal PIR sensor, which is going to be connected to the Arduino board, which is going to be the pin number 2 to be exact, from the output of the PIR sensor to the pin number 2. From there, it's going to run a code and output a high if the output for the PIR sensor is also high. And once the PIR sensor is high, the Arduino Uno board will output a high output from the pin 12 to the board into the green LED. Once it's high, the green LED will turn on. If not, the red LED will remain on. So that's basically how it works from the flowchart over here. From the beginning, it checks if there is a motion nearby the PIR sensor, and the output will be set to low and the red LED is on. However, once there is a motion near sensor, it will determine whether yes or no. If yes, the output will be set to high and the green LED will turn on, as well as an increase in the increment of the counter. However, if not, the output will still remain as low and the red LED will remain on. Over here we have a graph which details how the sensor relays information over a 3-day period, starting from New Year's Eve until the 2nd of January 2025. We can see for the 31st of December 2024 that it peaked at around 11 o'clock to 12 o'clock, in which there were about 46 people, 46 transactions to be exact, but it dipped around 12 o'clock at 27 was when there were fireworks. It should be noted that everything over here starts from 10 a.m. in the morning until 12 a.m. because that's how the cafe, that's the operating hours of the cafe. And we can see over here, there was a trend that after New Year's Eve, the amount of customers that entered the cafe was way less than New Year's Eve. This was probably because New Year's was when there were the most number of customers due to an event being held nearby the cafe, which was in Jogja. And over here we have the Tinkercad of the whole circuitry. It should be kept in mind that in order for the red LED to work, I also used an IC7404, which is a hex inverter. So when the output from the PIR sensor enters the Arduino Uno board, pin 2, and pin 12 outputs to the green LED input, which is over here, it's also going to go to the input of the IC7404. Now, the output of the IC7404 is going to enter the input of the red LED, which is going to be grounded. So if, for example, it's not connected to anything, if the PIR sensor is not detecting anything, it's going to be the red LED is going to be turned on because over here the input is 0 and the output is going to be 1. So the red LED is going to be turned on. If, for example, there was going to be a motion nearby, the output over here will be 1, which will turn on the green LED and in turn turn the input of this IC7404 into 1. Therefore, the output will be 0, and thereby the red LED will not be turned on. On the right side over here, we have our code, which starts with the end state bool detect, which is basically either true or false. I have set it to false because this is in the beginning. And then we also have a counter, which counts how many counts it's going to detect. After that, I also added a millis in order to count how many milliseconds it took for the and the milliseconds it took for the circuit to run. And it's going to be running in an interval of 1000 milliseconds, which is around 1 second. It should be noted that I also tried to use an RTC lib library. However, it needed an additional component for the RTC, so I decided not to use that. Also, over here we have the void setup, which is to show that the pins that are going to be used are pin 2 and pin 12. And pin 2 is going to be the input, and pin 12 is going to be the output. Over here, for the void loop function, I utilize the millis as I mentioned before, in which C millis is going to be the current time which has elapsed. Next, over here, it's going to be the state, which is going to be reading the state of pin 2 because it uses the digital read function. And over here, we have an if statement that says that if the state is high and there is the not detect, so it's going to be true, so it's going to be high. Digital off is going to be, by the way, for pin 2. Digital write will be 12. Digital write, which is going to be in pin 12, is going to be set to high, and the detect, which is going to be true. Therefore, the counter will go up. And over here, we also have that, and we're going to have to make it much more user-friendly by saying that there is a motion detected nearby the PIR sensor, and it's going to be purchase is going to be whatever the purchase is going to be. For example, it's going to be go up from 0 to 1 when there is a motion, when it just started. And then there is an else if statement also that if the state of is low, then the digital write for pin 12 is also thereby going to be low, and therefore the detect of the bool detect is still going to be false. Over here on the end is the if statement for the time. So it's going to be going to take it's going to be ticking every 1 second, because over here it says C millis divided by 1000, and we know that 1 second is basically 1000 milliseconds. So we're going to have to divide that value. So over here we have serial.print seconds elapsed, in which it's going to print out the time in seconds. I also added a delay of 4000 so as to not overlap the people who are going to be who are going to do the who are going to be paying, because well, I have tried this before the 31st of December, and it seems that by having, let's say, 500 for the delay, it's a bit too quick, and I found out that 4000 is much more suitable for our operation. Moving on, over here we have the output. Over here it's just the program again with the counter and everything. And over here we have the seconds elapsed. So basically these are the purchases which are done on December. It was very full, and there was a bit of a problem in the end because I accidentally turned off my laptop, so I had to do it again. And over here, we can see that when there is motion, it detects the purchase, which is going to be 25. And over here, 10 minutes has elapsed, seeing as there is 664 seconds. So more into 11 minutes. And over here, I have my references, which details everything that I researched and was able to compile. Over here, we have our motion sensor, our data sheets for the Arduino, the Atmega microcontroller and well, the technical data. That's all for me today. Thank you. And now I'm going to be showing how the Arduino works for the for here. You can see that it's in Tinkercad. And if we start the simulation, we can see that in the beginning, since there is no motion at all, the red LED will be turning on because, well, the anode is going to be connected to the output and everything is still zero. This is still going to be zero. It's going to be on. Now, if we were to add a motion here, it's going to be turning green. And note that there is a delay because the 4-second delay, because that's what I set for the code, which is over here. And it's going to be the same as the code before. Okay. I think that's all from me from today. Um, oh, yeah, maybe I'll talk about some of the issues that that arise during this. Initially, I wanted to make a customer counter. However, due to the unavailability of a place to actually put my PIR sensor without making it looking less attractive, it's not really possible, and it might be a bit suspicious for other customers. And in addition, we did not have a tip box for our cafe, so I decided to create it along with the cardboard. It may not look as good as I want it to be, but it will have to do right now. So I think that's everything from me. Thank you for listening to my recording.